There are some problems in astrophysics that can't be solved on a normal computer. For this, we use a supercomputer. My name is Ryan Tanner. I study active galactic nuclei and star formation and how they affect galaxies. I have been doing research and computer simulations of galactic outflows for a number of years now.
My name is Kim Weaver and I work at NASA. I've been looking at AGN for a very long time, and we just don't understand how the jets impact the galaxies in these low luminosity objects.
An AGN is where you have a supermassive black hole at the center of a galaxy, and occasionally there's gas or a star or something that gets too close to the supermassive black hole, and it begins to get pulled in by gravity. But when it does that, it releases a huge amount of energy.
There are strong jets and weak jets. High-intensity AGN, the large jets, have been studied for a long time. We've seen, they're very obvious. You can see them on the sky. You see them bright in the radio emission. You see them bright in the optical.
The largest ones can get several million light years in size.
The low luminosity jets are much harder to find and often do not even leave their galaxies and are very compact.
We know some things about the AGN, but we don't know everything. It's like a big puzzle piece. We're doing a jigsaw puzzle, and there's pieces that are missing, and there's some that we have fairly well put together, but others where we have no idea what's there. One of the major puzzle pieces that we're missing is how these low luminosity AGNs impact and determine the evolution of their host galaxies. For this problem, we have to use supercomputers. For my research, I use a code called Athena. It can do anything from planet formation, star formation, supernovas, and anything in between. And I did some modifications to it in order to tailor it to my exact problem that I have.
The process of watching this was impressive because, there's so much computation going in and there's so much focus going into this project, and the outcome is going to be something pretty spectacular, but it takes time. So Ryan came to me and said, I need a supercomputer, and I said, okay, what? Because I had never helped anybody get the supercomputer time. I've seen it, I've been in the room, it's amazing. You submit a request online in the system.
You have to provide a justification for what you're going to use. You have to explain the project behind it. You have to explain basically what you expect to get out of it and how you will use those results. And that goes through a review process that can take several months. The formal review process can take anywhere between 6 months up to, I've been told, 18 months. Basically, I can use the supercomputer from anywhere in the world as long as I have a secure connection to it. And then once I'm logged on to it, it's as if I'm there using the supercomputer in the actual building where it's housed. I can upload the code that I need to use to run and any data files that need to go in for inputs. And then I can simply use a command to submit a job on the supercomputer, and it puts it in a long queue of different people who have submitted jobs on the supercomputer.
All I can tell you is there were days that I asked Ryan how things were going, and he said, it's going to be another few days because I have simulations running. So for the paper that we wrote for this particular result, it was about 800,000 hours of computational time.
When I'm actually doing the research and doing the simulations, like I said, I don't think too much about it, but when I talk to other people and explain what I'm doing, that's when I realized, oh, these are really big simulations, and there's a lot of stuff going on here that most people will never see, or the amount of computational resources that most people will never use in their life. So using the supercomputer and getting the simulation data back was a process that just continuously would do it over several months. I would have to run a simulation, download the data, look at it, see if it was doing what I expected it to do. If there was anything that was wrong, I had to go back and figure out what was wrong with the code. Then I would make that change to the code on the supercomputer, run the simulation again, download the data, look at it, and just repeat the process over many, many months, over basically a year.
Fact is, sometimes it can take decades to make things happen, but you have to have the patience, and hopefully that's what most astronomers have, and they need is patience, because the universe doesn't always bend to your will, and you have to wait to find out what's going on.
It was one of those things where I didn't know exactly what would come out of the simulations. That's why we're doing it. And that's sort of the case as it was here. It was, we run the simulations and then something unexpected came out. Oh, these AGN, these low power AGNs actually have a very large impact on their host galaxies.
The blue color in the center, the blue-green colors indicate the galaxy itself. But when you see the pink colors that are coming out and the purple, that is the actual jet itself.
The jets can be split. They can be split by a dense cloud into streams as they come out of the galaxy. They can be deflected, which is they change direction entirely. And in some cases, the jet can be entirely stopped. Are
we seeing star formation that's being created by the jets impacting the clouds, which I think would be really cool, because again, that says the black holes are doing something amazing to the galaxies by being there. Or we could see that the jets could be disrupting the star formation and slowing it down, which is another possibility. And those two things, we don't know yet. Which one is the right answer?
The two major things to draw out of this is just how complex these jets are because they interact with their host galaxy. They're not simple, they're not nice, smooth outflows. The other thing is that these low-power AGN jets, the galaxy determines what the jets look like to a greater degree than has been assumed before.
I never thought I'd be involved in a project that uses a supercomputer. So to me, it was a bit of an alien thing. And so I was fascinated that we actually were doing this. And yes, when I saw the results that came out, I was impressed, I was excited.
Just a very exciting thing to study, something that is so incredibly new to everybody.